Hi friends, today we are going to discuss about astronomers just detected possibly the largest rotating structures in the universe. Although the night sky changes very little on human timescales, the universe is not a static place. We wheel about in motion around the galactic center, stars are born and die in violent explosions, galaxies collide. And for the first time, astronomers have just found evidence that some of the largest structures in the cosmos rotate on a scale of hundreds of millions of light years. If validated, it would represent the largest rotating structure ever seen, suggesting that angular momentum can be generated on absolutely mind-blowing scales. The structure in question is a cosmic filament, a long, cylindrical structure of dark matter, spanning intergalactic space as a sort of bridge between galaxy clusters. These filaments are strands of a vast cosmic web via which galaxies and star-forming material are channeled into the cluster nodes. This means galaxies can be found along the filament too, not just within the clusters. This gives scientists a tool for identifying rotational motion within the filament itself. By mapping the motion of galaxies in these huge cosmic superhighways using the Sloan Digital Sky Survey, a survey of hundreds of thousands of galaxies, we found a remarkable property of these filaments: they spin, said astrophysicist Peng Wang at the Leibniz Institute for Astrophysics, Potsdam, in Germany. The filaments are hundreds of millions of light years in length, but just a few million light years in diameter. On such large scales, we won't be able to see the galaxies actually moving. But luckily for us, the light of a moving object still gives it away. It is called Doppler shifting, changes in the wavelength of light depending on whether it's moving towards or away from the viewer. Wavelengths of light from an approaching object will appear to shorten slightly towards the blue end of the spectrum, or blue shift. Wavelengths from receding objects will lengthen or red shift. Be carefully studying the light from galaxies on cosmic filaments and comparing them to each other. Astronomers found that galaxies on one side of the filament were redshifted in comparison to the other side. This is exactly what you would expect to see if the galaxies were in the vertical motion perpendicular to the filament spine. On these scales, the galaxies within them are themselves just specks of dust, explained cosmographer Noam Libeskind of AIP. They move on helical or corkscrew-like orbits, circling around the middle of the filament while traveling along it. Such a spin has never been seen before on such enormous scales, and the implication is that there must be an as yet unknown physical mechanism responsible for torturing these objects. Figuring out what that mechanism is could help astronomers figure out how angular momentum is generated in the cosmos. Currently, it's a mystery. In the early universe, according to our cosmological models, there was no rotation. Matter moved from less dense to more dense regions. One theory, described as tidal torque, suggests the presence of shearing force might have added a bit of a twist. But we simply don't know how enough to even begin to take it seriously in models of cosmic evolution. Because galaxies are connected and fed by cosmic filaments, these structures play an intimate role in the formation of evolution of galaxies, including their rotation. However, whether the filaments themselves spin had previously only been theorized. The discovery that they do will help us better understand the emergence of angular momentum in the universe and the role the cosmic web plays in regulating it. It's fantastic to see this confirmation that intergalactic filaments rotate in the real universe, as well as in computer simulation. Thank you friends, thanks for watching. Subscribe for more interesting like videos.